Okay, guys, we're going to go over the acceleration notes real quick, okay, so that you know how to do these. And then that way you'll be able to handle your assignment today. All right, so today we're calculating acceleration. All right. Acceleration is the change in velocity divided by the time interval in which the change occurred. So that's like the textbook definition. All right, and that's how we get the equation. All right. So the first thing you got to understand is there's going to be a change in velocity. So how to find a change in velocity? Change in velocity is always final velocity minus the initial velocity. Okay. Now, initial, that just means starting. So whatever the starting velocity is. Now, you can have two different kinds of change in velocity. And change in velocity is written like this little triangle V. That's actually not a triangle. It's a delta, but that just means change in. So change in velocity. Positive change in velocity means that you're speeding up. Okay, so if you get a positive change in velocity, the thing will be going faster. If you get a negative change in velocity, which will happen on your homework, so you're going to see this on your homework, okay? And if you get it, that's okay. It means that you're slowing down. That's all that means. Okay, so if you get that, don't freak out about that. That's what you're supposed to do. All right, then I have two find the change in velocity problems for you. And so for A, I have two. So VF, which one do you think that would be? You think that'd be final velocity or initial velocity? You're right, that's final velocity. I have as 10 meters per second, and then the initial velocity I have as 3 meters per second. So we're supposed to find the change in velocity. Oh, this is no big deal. This is just final velocity minus initial velocity. So it's 10 minus 3, and so we get 7 meters per second. Because this is 10 meters per second, and this is 3 meters per second. When you subtract them, you just get meters per second. For B, the final velocity is 10 meters per second, and the initial velocity is 15 meters per second. So when we find the change in velocity, remember it's final minus initial. It's not big minus small. It's final minus initial. The final is 10 minus the initial, which is 15. That means we get negative 5 meters per second. That's okay. That just means we slow down. So if I start at 15 and end up going 10, that's what that means. I slowed down. I went slower. So the equation for acceleration is A equals the change in velocity over time. All right. Or if you want to, you can rewrite the change in velocity here as VF minus VI over time. Either is fine, and if you want to find, it really doesn't matter which one you go with. The first version is fine, the second version is fine. It really doesn't matter, okay? All right, so example 1 from your notes page says, a car accelerates from rest to 75 kilometers per hour in 10 seconds. What is the acceleration? Okay, so from rest, remember rest means not moving. Rest is your favorite thing because rest means 0, and that's the easiest number. So if we look at that real quick, that means the initial velocity is 0 meters per second. The final velocity, that's how fast we ended up going, is 75 kilometers per hour. And you know what? I should probably change my units here. I should keep them the same. Sorry. So that's 0 kilometers per hour. And the time it took was 10 seconds. So I would just write my equation. Change in velocity over time. So what I'm going to do first is I'm going to find my change in velocity, which is just VF minus V naught, or V initial. So that's 75 minus 0 all over 10. And I'm done. Okay, so 75 divided by 10 ends up being 77.5. And then the units would be, since these are kilometers per hour, be kilometers per hour per second. And that would be my answer for number 1. Okay. If you feel like you're confident, go ahead and hit pause and try number 2. And then I'm going to work number 2 here in just a second. And you can see how you did. So go ahead and hit pause now. If not, just let it keep playing and I'll work number 2 right now. All right, so my computer's not working here. Hold on a second, see if I can get this to work. There we go. All right, example number 2. All right, so example number 2. What is the acceleration of an airplane that decreases its speed from 400 miles an hour to 250 miles an hour in 60 seconds? So we get a decrease in speed. So that should tell you that we're slowing down. That should also tell you we get a negative change in velocity. All right, so acceleration is final minus initial over time. You notice I'm going back and forth between the 2 types of equations. That's okay, you can too. The final velocity is where we ended up. That was 250 minus 400. That was where we started, divided by the 60 seconds. All right, so 250 minus is a negative 150, which is what we think it is. All right, divided by 60 comes out to be negative 2.5. And the units on these were miles per hour. And the units here were seconds. So the units that you'll end up with are miles per hour per second. All right, you go ahead and try number 3, hit pause, and then I will work number 3 as soon as I'm done here. Okay, so here's number 3. An object at rest is accelerated to 20 kilometers per hour in 10 seconds. What is the acceleration? So remember, from rest is our favorite. Write the equation. Final velocity, that's where we finish, minus the initial velocity, that's where we start, over time. So our final velocity is 20, I'm going to try to put the units in, kilometers per hour, minus 0 kilometers per hour, because that's rest. So remember, that's what we started from rest on this one in 10 seconds. And so 20 minus 0 is 20, divided by 10 is 2. So 2 kilometers per hour per second. And that's good there. All right. Let's go down and talk about, well, the second form of the equation. Well, the second form of the equation is when we solve for time. Okay, so they can ask how long. So to solve for time, what we'd have to do is we'd have to rearrange this equation by doing a little algebra. Okay, and so I'm just going to do that algebra right now. You're not going to be expected to do this. You'll be given this equation, so you don't have to worry about this. So t is equal to the change in velocity over the acceleration. That's how you get time. So you're going to want to use this equation if they ask for a time, right, and give you an acceleration. So let's try example number 4. Okay, so example number 4 is a car that was at rest accelerates at 5 meters per second. How long will it take to reach a speed of 40 meters per second? Okay, so here our initial velocity, remember, was at rest at 0 meters per second. The final velocity, that's how fast we were going at the end, is 40 meters per second. And then they tell us the acceleration is 5 meters per second. So we're just going to use this equation right here that we saw to find the time. So time is change in velocity over acceleration. Remember, change in velocity is just v final minus v initial over the acceleration. And so v final is 40 meters per second minus 0 meters per second, all over 5 meters per second. So This is fun for me. I get to kill the meters and the seconds, and I end up with, so because that just goes away, 40 divided by 5 is 8, and so what's left alive is just seconds, so I get 8 seconds. That's my answer there. All right. Okay, so if you think you're pretty good at this after one example, go ahead and work example 5 and then hit play again so you check and make sure you're doing it okay. And then hit play again as soon as you're ready. And again, I'm going to work this one. If you want to stay on and watch me work with this one, here I go right now. A plane increases speed from 300 miles an hour to 450 miles an hour with an acceleration of 3 miles per hour per second. How long did it take? Okay, so we're going to use this equation. Change in velocity over A. So the change in velocity would be my final velocity, which was 450, minus the initial, which is 300. And those units are miles per hour, all over the acceleration. That's a 3 miles per hour per second. Miles cancel, hours cancel. We're left with seconds. This is 150. So 450 minus 300 is 150 divided by 3 is 50. So it took 50 seconds. I know it's seconds because that's what's left alive. All right, so same thing on number 6. Hit pause, work number 6, and then come back and check the answers yourself. So here's number 6. A car accelerates at 2.6 meters per second. How long does it take to accelerate from 24.6 meters to 26.8 meters per second? So we're just going to use the same equation. Yeah, I know the numbers are a little weird. That's okay. So my final velocity, it says from 26.8. That's the final. What we get to, that's 26.8, minus the initial. That's what it says from 6 meters per second, all over 2.6 meters per second. So the meters are going to cancel. One of the seconds is going to cancel. That's going to be left alive. So now when we punch this in, 26.8 minus 24.6 is 2.2 divided by 2.6, and we get a weird number, but that's okay. That's what the calculator's for, 0.846 seconds, so a little less than a second, and we get it right there. All right, so do this. Once you've done this worksheet right here, go ahead and start on the acceleration problems. On the acceleration problems, your assignment is 1 through 8. Number 9 and number 10 are bonus. All right, have a good day.